Good morning, students. Today I am going to take up linear differential equation with constant solution in series. Solution in series or Frobenius method. It's a mathematician Frobenius. The method is given by Frobenius. That is why it is known as Frobenius method. Now see, you have already solved equations of the form if this P, Q and R are constants, then this is a linear differential equation with constant coefficients. This is a second order linear differential equation. If this P, Q, R are variables, then this is a linear differential equation with variable coefficients. Solution, you already know how to solve such equations. You have to find the complementary function. For that, you have to find the auxiliary equation. Roots of the auxiliary equation may be real and different, may be equal and may be imaginary. In each case, solution is of the form e raised power mx type, either in terms of cos or in terms of sine. And when it is variable, see, if you have two roots m1 and m2, you know what is the solution? Complementary function. It is c1 e raised power m1x, c2 e to the power m2x. You know it. If they are equal, then complementary function in this case is c1 plus c2x e to the power mx. And if they are complex, say alpha plus minus I beta, then your complementary function is e to the power alpha x, c1 cos and c2 sine. This you already know. Okay. Now, let me tell you, e to the power mx. This is actually or e raised power x. This is 1 plus x square by factorial 2, x cube by factorial 3, plus so on. Sin x, it can be written in terms of x minus x cube by factorial 3, x5 by factorial 5, so on. Cos x, 1 minus x square by factorial 2, x4 by factorial 4, minus so on. You know, each one of them has a series solution actually. This e to the power m1x, this can be written in terms of a series. Sine and cos, this can be written in terms of a series. E to the power mx, this is a series. So actually, the solution of linear differential equation with constant coefficient is a series, right? If these are p, q and r are variables, then you already know what we are doing. We put x equal e to the power z and reduce a linear differential equation with variable coefficients into a linear differential equation with the constant coefficient and proceed likely. Solution are same. And the final what we do, solution will be in terms of z, and then z is log x, and log x has also a series solution, log of 1 plus x, log of 1 ax plus by, okay, ax plus b, etc. Okay, then means I want to emphasize that the solution of these are in terms of e to the power mx, sine and cos, which can be represented in terms of series. Now this question can be, how to solve these equations and how to reduce a linear differential equation with variable coefficient into a linear differential equation with constant coefficient. Problem is that for p, you must be having x square. For q, you must be having x, means first derivative will along with x, second derivative along with x square. Homogeneity must be there. If it is not the case, if you have x and second derivative and you don't have anything with the first derivative, or you have x square with the first derivative, you cannot solve such equations. For such equations, you have a question, say you have x into 1 minus xy double dash minus 2xy dash plus y equals 0. See, This is a linear differential equation with variable coefficients, and you cannot solve it by substituting x equal to e to the power z, because homogeneity is not there. Okay, you cannot use Euler's method, putting x equals z and then transforming a linear differential equation into variable coefficients into a linear differential equation with constant coefficients. So there must be some other method to solve such equations, which cannot be solved by ordinary methods. Such equations are solved by using a method known as Frobenius method. Now, what is the Frobenius method? I have already sent you notes yesterday. I hope you must have gone through those notes. I will just explain what is written there. If you have a linear differential equation with constant coefficient or variable coefficient of this form, what we suggest is that we assume that egg y equal x raised power c, a0 plus a1x plus a2x square plus so on, a0 not equal to 0 is a solution of this differential equation. Which differential equation? P d2y dx2 plus q dy by dx plus ry equals 0. This is one. We are solving equations of this form only, but then if we are not able to solve them by usual methods, then we use a series known as Frobenius series. This is the series which we use. We suppose that this is a solution. What we do is that if this is a solution, then this can be written as x raised power c summation r running from 0 to infinity ar x raised power r c. When r is 0, this is a0 x raised power 0, which is a0, a1 x raised power 1, a2 x raised power 2, so on. Or finally, you can write it in this form, because I will be writing throughout this form. This is ar x raised power c and x raised power r. This is c plus r. This is a solution. We suppose that y equal to ar x raised power c plus r is a solution. A0 is not equal to 0. Okay. Okay. So when we know y, we can always find y1. y1 is the derivative of this. Y is the function of x. So what is the derivative? Derivative is ar c plus r x raised power c plus r minus 1 x raised power n x raised power n minus 1. This is the first derivative. Then what is y2? Summation r running from 0 to infinity ar c plus r, then again x raised power n is n c plus r minus 1 x raised power c plus r minus 2. So when I know y, I know y1, I know y2, I substitute these values of y, y1 and y2 in 1. I will get a series. Then I collect coefficients of different powers of x starting from the lowest. Collecting coefficients of different powers of x starting from the lowest. The lowest degree equation, when equated to 0, gives us a quadratic known as indicial equation. Indicial equation. From that indicial equation, we are able to find the value of this index c. The coefficient of lowest degree term, when equated to 0, gives us a quadratic. Always, because this is a second order differential equation, we will always get a quadratic. That is known as indicial equation. The indicial equation, since this is a quadratic, its roots will be there. Okay, two roots will be there. So those two roots gives us the index c. This is known as indicial equation because index is involved and we get values of c. Okay. Now collecting coefficients of different higher powers of x now, starting from the lowest, you get coefficient of this a0, constant a0, a1, a2, so on. Substitute in this the values of a1, a2, so on. You get an equation of the form when you substitute. You see what we are doing? I will explain it again. You know what is y. You are taking a series y. You know what is y. It's a series in terms of these constants and this index c. You find y1, you find y2, substitute in 1, you will get a series. Then you collect coefficient of different powers of x, starting from the lowest. first coefficient when equated to coefficient of first term, lowest term, when equated to 0 gives us the initial equation from which we get values of C. And from other coefficients we get values of this A1, A2, A3. That is always in terms of A0 we will see, and we get finally equation of the form A0 x raised power C some function of x and C. This will be our solution. Now, okay, this is the working rule. You know y, you are finding y1, you are finding y2, and you find finally y in terms of a0 x raised power c and some function of xc. Now, I have said that you can find this everything. Now, values of c, this is the quadratic when I have said that this can be obtained from an initial equation, a quadratic equation. The values of c, there will be two values of c, say alpha and beta. For these values of c, we have four different rules. Now, rule 1 is that if you have, you can put your notes which I have already forwarded to you yesterday. You can put it in front of you. You can see case number 1. If roots of the initial equation are different, alpha and beta, not differing by an integer, their difference is not an integer. Say you have alpha equal to 0 and beta equal to 1 by 2. Then see, their difference is not an integer. If you have such a case, you have two different roots and not differing by an integer, then a solution is obtained by first putting alpha c equal to alpha. If this is 2, we put c equal to alpha in 2, we get one solution. For c equal to beta in 2, we get another solution. Then general solution is given by c1u plus c2v. Right? For two different values of alpha and beta or c, we get two different solutions, and by superposition principle again, the general solution is given by c1u plus c2v. Now, case 2 is that if you get repeated roots, say you have c equal alpha and alpha, then first solution is given by this. You see, I am getting a0 x raised power c some function of x comma c. This is 2. First is differential equation. I am finally getting this solution. Okay. Now, for first case was that I am getting two different roots alpha and beta. By substituting alpha, I get one solution. By substituting beta, I get another solution. General solution is given by c1u plus c2b. Now I have two equal roots alpha and beta. Then first solution is given by putting c equal to alpha in 2, and second is given by putting c equal to alpha in del y by del c. But what is del y by del c? Del y by del c is y log x plus a0 x raised power c del by del c of function of xc. Because if you differentiate this function with respect to c, you know what is differentiation of a raised power x? With respect to x, it is a raised power x log a. Differentiation of a raised power x with respect to x is a raised power x log a. So, if I will differentiate this with respect to x, you have two different functions of x. First, you will get a0 x raised power c as it is, differentiation of function of xc, that is this one. Then you have a0 function of xc as it is. Then you have differentiation of x raised power c, it is x raised power c log x. Because differentiation of a raised power x is a raised power x log a. You have x in your base. There was a in the base. So you have x raised power c log x. This is y as per this. So this is y log x, a0 x raised power c del by del c of xc. So you put one value in this 2 and another value is in 3. Okay. Now why do we take del y by del c as a solution? Again, you can see page number 113 which I have forwarded to you. You can see that this is exactly the solution. When we substitute the values in this is exactly, we get the identity. Okay. Case third is that Again, C is alpha and beta. My first case was roots are different, not defining by integer. My rule third is that roots are different and they are differing by an integer. Say you have 2 and 0 and 2. Their difference is an integer. Whether 0 minus 2 or 2 minus 0 is an integer. Okay. So two cases arise. One case is that roots are different, differing by an integer but making some of the coefficients infinite. You get some of the coefficients infinite. Say C equals alpha. If I put C equals alpha in 2, I get some coefficients. Say there are coefficients, say A1, A2, A3, so on. Some of the coefficients we get infinite. Then what is to be done is that we modify the form of C. Modify the form of C by not C, this Y. Because in this, all the coefficients are in Y. We modify the form of Y by replacing A0 by K times C minus alpha. If C equal to alpha is the roots which makes some of the coefficients infinite, then I replace A0 by K times C minus alpha, C minus alpha. If it is minus alpha, then C plus alpha. If it is 2, then C minus 2. If it is minus 5, C plus 5. Okay? Got it? Then, the two solutions. When I will change A0 by K times C minus alpha, I will get a function of this form. See, Y will be K x raised power C, some other function, say psi, x and C. This function will change because you will see later on this will be a changed function. This will not be this function psi. This will be some other function. So I will get one solution from this and another solution from its solution from its partial derivative del y by del c. Okay, this is the third method. If roots are different and differing by an integer, then and making some of the coefficients infinite, then I modify the form of y and solution is given by that modified form of y and it is partial derivative. Okay, and finally rule 4 is that I have two different roots alpha and beta dividing again by integer, but making some of the coefficients indeterminate. Coefficients are not infinite now, they are indeterminate, 0 by 0 form. Okay, then what I will do that, say C equal to alpha is the root which makes the coefficients of y indeterminate. Then what is to be done? I have to substitute the C equal to alpha in the y only. I don't have to do anything. Putting C equal to alpha in y, I will get two different solutions. We know general solution is given by C1u plus C2v. I will get both these series, one series and another series, just putting C equal to alpha in y. Another value, beta, is not to be given because you will see yourself, if you will substitute C equal to beta in this, I will get any one of these functions. Either I will get u or v. Okay? So there is no fun of substituting another value beta. Same is the case with infinite case. I have chosen, say, C equal to alpha makes the coefficients infinite. I don't have to use beta because you will see I will again get some the solutions which are already obtained by putting C equal to beta. So beta is not to be put in both the cases, whether it makes infinite or indeterminate. Okay, I hope I am able to convey you. Now everything will be clear through examples. Now let me take up an example. Suppose I have an example 4x 2 4x y double dash plus 2y dash plus y equal to 0. Means 4x y2 2y1 plus y equal to 0. This is 1. Okay. Now, let me suppose, using Frobenius method again, let me suppose that let y equal x raised power c a0 plus a1x a2x square plus so on be a solution of 1. This means ar x raised power r be a solution of 1, or let y equal, in future I will be writing directly this one, let y equal summation r running from 0 to infinity ar x raised power c plus r be a solution. Okay, then y1 is summation ar c plus r x raised power c plus r minus 1, and y2 is summation ar c plus r c plus r minus 1 x raised power c plus r minus 2. This is y, this is y1, this is y2. In future examples I will be writing y1 is y is this, y1 is this, y2 is this. I don't have to write anything else. Huh? So let me substitute y, y1, y2 in 1. Okay. See, I am not writing r running from 0 to infinity. You have to write it. Huh? If I will not write, you will write for always r running from 0 to infinity. You have seen why we write r running from 0 to infinity. So substituting y, y1, y2 in 1, we will get substitute y, y2, y, y1, y2 in 1, we will get 4x y2. We have seen ar c plus r c plus r minus 1 x raised power c plus r minus 2. This was my y2. Then y1, this is summation ar c plus r x raised power c plus r. This is c plus r minus 1. This is my y1. And my y is summation ar x raised power c plus r equals 0. This is y, this is its first derivative, x raised power n, and x raised power n minus 1. This is its second derivative, c plus r minus 1, x raised power c plus r minus 2. Or, you see, bases are same, powers are added. This is x raised power 1, this is x raised power c plus r minus 2. So you have 4 ar c plus r minus 1, x raised power c plus r minus 1. Then twice ar c plus r x raised power c plus r minus 1 plus, or you can write it as equal minus summation ar x raised power c plus r. I have taken ar c plus r on the right hand side. This will be minus times. See, this is power x raised power c plus r, x raised power c plus r. And what is common? 2 times ar c plus r. 2 times ar c plus r. So this is summation twice ar c plus r. What remains is 2 times c plus r minus 1 plus 1 x raised power c plus r minus 1 is equal to minus summation ar x raised power c plus r. Okay. Or finally I have summation r running from 0 to infinity twice ar c plus r 2c plus 2r 2c plus 2r minus 2 plus 1, so minus 1 x raised power c plus r minus 1 is equal to minus ar x raised power c plus r. This is it. Now what is the method? You cannot simplify it further. Okay, this is to be done. This is to be ensured that you cannot simplify it further. This is what we have. Now, my r runs from 0 to infinity. Let me let me open it. When r is 0, left hand side first. R is 0. This is twice a0. C plus 0 is c. Then 2c plus 2 into 0 minus 1. X is power c minus 1. R is 0. 2a0. C plus 0 is c. Then 2c, 2r is 0. 2c minus 1. X is power c minus 1. Okay. Now when r is 1. Twice a1. C plus 1. 2c, r is 1. 2 into 1 minus 1. 2c plus 1. X is power c. Fine. Now r is 2. a2. C plus 2. 2c. 2 into 2 is 4. 4 minus 1 is 3 plus 3. X is power c plus 1 plus so on. You will get x is power c plus 2. X is power c plus 3 and so on. And right hand side is minus a0 x is power c. a1 x is power c plus 1 plus so on. a0 x is power c plus 0. a1 x is power c plus 1. Then a2 x is power c plus 2 and so on. Now what I have said, collecting coefficients of different powers of x, this is very important. Up to this, now what you have to collect? You have to collect coefficients of different powers of x starting from the lowest. The lowest coefficient, as I said, will be a quadratic equation known as the initial equation. Okay? So collecting coefficients of different powers of x starting from the lowest. You see, lowest coefficient. Coefficient of x is power c minus 1. This is c minus 1. It gives twice a0 c into 2c minus 1. And right hand side you don't have x is power c minus 1. So right hand side is 0. You have to collect coefficients on both sides. Okay? Collecting coefficients of different powers of x starting from the lowest. Your lowest coefficient of x is power c minus 1 is this one. Since a0 is not equal to 0, 2 is not equal to 0, so either your c is 0 or c is 1/2. You see, you can judge from here. Roots are different and they are not differing by an integer, so you have to apply rule 1. Okay? Now coefficient of x is power c. You have already got values of index c. Okay? Now you have to find values of a1, a2, a3, so on. Now coefficient of x is power c. Twice a1, c plus 1, 2c plus 1 is equal to a0 minus a0. X is power c, x is power c. Here coefficient is this, here coefficient is minus a0. So your a1 is minus a0, 2 times c plus 1, 2c plus 1. Fine? Now, coefficient of x is power c plus 1, c plus 1, c plus 1. Okay. Coefficient of x is, this is a2, c plus 2, 2c plus 3 is equal to c plus 1, it is minus a1. But your a1 is in terms of a0. So a2 is minus minus plus a0, c plus 1, 2c plus 1, then c plus 2, 2c plus 3, and so on. So you have got a1, a2. Obviously, what will be a3? a3 will be in terms of a0 again. You will have c plus 1. See, you can judge from here. C plus 1, 2c plus 1. C plus 2, 2c plus. Then c plus 3, 2c plus 5. And so on. Okay, you can judge it. You can find the reconciliation also, but for beginners, this is okay. You can see yourself. There is a coefficient, right hand side it has no coefficient, so right hand side will be 0. There is a coefficient. There is a coefficient with x is power c. There is also coefficient with x is power c. So this is to be combined. Then there is a coefficient with x is power c plus 1 here over here also. So this is to be combined. but then your a1 is in terms of minus a0, so this will be plus a0. So you have got a0, you have got values, you have got a1, you have got a2. Now let me substitute the values in the assumed trial series. Hence, from the assumed trial series, or substitute the values of a1, a2, substitute the values of a1, a2, so on in the assumed trial series. What was the trial series? X raised power c, a0, a1x, a2x square plus so on. This is equal to x raised power c, a0 plus a1, this is your a1, minus a0x twice c plus 1, 2c plus 1, plus, this is minus, then this is plus a2. It is a0 x square twice c plus 1, 2c plus 1, then again, you see, this was twice, and this is again twice c plus 2, 2c plus 3, minus so on. Last will be plus minus, and so on. Okay, this is 2 over here, this is again 2 over here, you can see. Okay, I have not written it there. Okay, fine, this is okay. So let me, now what is the method? What is the method? There may be mistake also, this is a very lengthy one, so you can just see what is the method. So this is y equal a0 x raised power c 1 minus x upon 2 times c plus 1 to c plus 1, then x square upon 2 square c plus 1 c plus 2 to c plus 1 to c plus 2 minus so on. This is it. This I have denoted by y equal a0 x raised power c, and this is function of x and c. This is function of x and c. You can see yourself. This is 2. This is 2. Now up to this, let me tell you, in each case, 4 cases, you have to proceed like this only. You will find, you have assumed y, you can find y1, you can find y2, substitute in the given question, you will get a series of this type. Series will be of always a0 x raised power c function of xc, except in terms of indeterminate case. Okay, a0 x raised power c function of xc. This is a0 x raised power function of xc. You have 2 different roots of c. Roots are different and they are not differing by an integer. So you have to put those values in this 2. When c is equal to 0, your y is a0 1 minus x upon 2. C is 0 over here. Then x square upon 2 square. This is 1, this is 2, and 2 square. This is 2c plus 3, okay. 2c plus 1. Then this is 2 and this is 3. Your c is 0, 0 plus 1, 0 plus 2, 2c, 0 plus 1, 0 plus 3. So this is it, minus so on. So your y is a0 1 minus x by 2 plus x square by 4, 624 minus so on. Say this is u. First solution. You have got the first one. Fine. For c equal to 1/2, you will get another solution. This is a series, you see. For c equal to 1/2, when c is equal to half, your y is from 2, a0 x raised power half, 1 minus x upon 2, 1 by 2 plus 1, it is 3 by 2. Then 2 into 1 by 2. 2 into 1 by 2 is 1, 1 plus 1 is 2. Then x square, 2 square, 3 by 2 and 2 you will get, because c plus 1 is 3 by 2, 2c plus 1 is 2, then 2c plus 2, it is 3, or sorry, c plus 2, it is 1 half plus 2, 2 to 4, 5 by 2, 5 by 2, then 2c plus 3, 2, it is 4, minus so on. So you have a0, x raised power half, 1 minus x by 6, 3 2s are 6, then 2 square goes 3, 5, 15, 15 to 4, 60. Is it okay? This is 2 square, then 1 by 2 plus 1, it is 3 by 2, 1 by 2 plus 2, it is 5 by 2, 3 by 2, 5 by 2, then 2c plus 1, it is 2, it is 2, then 2c plus is 4. Okay, now see what ये दो हम भूल गए थे. So this is x square by 3, 5, 15 into 8, 120. 120. This is plus, minus, plus and minus. This is V. And general solution is given by general solution y equal C1U plus C2V. This is the solution of such type of equations which cannot be ordinarily solved, which we are able to solve only with the help of Frobenius method. Okay, let me take up one more example. Nine x 1 minus x y double dash 12y dash minus 12y dash plus 4y equal to 0. See, this is the question. You know what is y, what is y1 and what is y2. This is what I will write. This is 9 x minus x square y double dash ar c plus r minus 1 x raised power c plus r minus 2, then minus 12 y dash ar c plus r x raised power c plus r minus 1, then y 4 ar x raised power c plus r is equal to 0. Fine. Now 9x into this, these are same powers are added. This is 9 summation ar c plus r minus 1 x raised power c plus r minus 1 x raised power 1, then x raised power 2 minus 9 ar c plus r minus 1 x raised power c plus r only, 9x square. So 9 is there, x square means x raised power minus 12 plus 2, then minus 12 ar c plus r x raised power c plus r minus 1, then 4 ar x raised power c plus r equal to 0. Okay, now c plus r minus 1 here, c plus r minus 1 here. What is common? arc plus r, arc plus r. You have 9, you have 12, you can even take 2, sorry 3. 3 4s are 12, 3 3s are 9. It's your choice whether you will take it out or not. It's your choice. So you have ar c plus r, then you have 9 times c plus r minus 1 plus 12. Plus 12 or minus 12? Minus 12. Minus 12. Okay? X raised power c plus r minus 1. Now you have x raised power c plus r over here, x raised power c plus r here. What is the common? Only ar. So minus and you are taking minus also. So you have minus summation AR C plus R minus 1 9 times 9 times AR you have taken outside, C plus R minus 1 and minus 4. X is for C plus R equal to 0. Minus 4 because I have taken minus outside. Now what will be finally? What I will get? I will get summation AR C plus R 9C plus 9R minus 9 minus 12, so minus 21. X is power C plus R minus 1 is equal to right hand side plus don't have space now. I don't have space available, so I will write from here summation AR C plus R, then 9C plus 9R minus 21. X raised power C plus R minus 1 is equal to, okay, I have not done anything else. AR C plus R, this is 9C plus 9R minus 9 minus 12, so minus. So this I will take on right hand side. AR is common. AR, what is inside? It is 9 times C plus R. Let me write it as it is, C plus R minus 1 minus 4. X is power C plus R. Okay, this is it. Now what I have to do, I will open up, or I can calculate from here only, but then for you I will open it. R is from 0. Now first left hand side, A0 C 9C minus 21, X raised power C minus 1. A1 C plus 1 9C minus 12. See, R is 1, 21 minus 9 minus 21 plus 9 minus 21 is 12. X raised power C. Then A2 C plus 2. Then 9C. 9 to 18. 18 minus 21. It is 3. X raised power C plus 1 and so on. So on. Okay. Right hand side is equal to A0 9C A0 9C because C R is 0, then C minus 1 minus 4. I'll keep this curly bracket over here. C is 0, 9C, C minus 1 minus 4. Later I will calculate it. X is power C. Then A1 9 C plus 1 C minus 4 C plus 1 plus 1. See, R is 1, C plus 1, C plus 1 minus 1, it is C only, minus 4 and so on. So you can do it now yourself. Let me give you one or two more steps. I will calculate coefficients of different powers of x starting from the lowest. I will get coefficient of x raised power C minus 1. What is that? A0, C, 9C and 21. I will take 3 outside. Okay, is it okay? If you are comfortable with this, the coefficient is A0, C, 9C minus 21 is equal to 0. This gives C is 0 and C is 7 by 3. I can take 3 outside. This is 3C minus 7, so 7 by 3. Okay, this is it. You have got the values of C, two different values of C. This is the initial equation. This is the quadratic, known as initial equation. Its roots are known as roots of the initial equation. You have got two roots, C equals 0, C equals 7 by 3. These are roots. They are different and they are not differing by an integer. So rule 1. Now coefficient of x raised power C. A1, C plus 1, 9C minus 12. And right hand side, C. You have with C you have this one. 9C square minus 9C minus 4. Can we solve it? Oh, no, keep it like this. It doesn't matter. Okay. So you have A1. You can find A1. Okay. Similarly, you can find A2. Just like in question number 2. You have A1 in terms of A0. You see, right? Yeah, is A0 over here. A1 in terms of A0. You will get A2 in terms of A0. A3 in terms of A0. So you will finally get y equal to x raised power 0 C A0 function of xc. Put value of C first, Z equals 0 first, then 7 by 3. You will get the two different solutions. General solutions given by C1u plus C2v. Fine. Let me take one more example. Question is x y double dash plus y dash plus xy equals 0. Xy double dash plus y dash plus xy equals 0. See, x y double dash, this is AR C plus R minus 1, x raised power C plus R minus 2 and x minus 1. Then summation AR C plus R x raised power C plus R minus 1. Got it? Y double dash is AR C plus R minus 1 x raised power C plus R minus 2. But x is here, so minus 2 and plus 1. So minus 1. This is y dash, which is this one, plus xy dash. This is AR x raised power C plus R. This is y and multiply by x. So plus 1 is equal to 0. Fine. Now these two are collect coefficient. This will be AR C plus R whole square. See, C plus R, AR, C plus R, AR, C plus R. This is C plus R minus 1 and plus 1. X raised power C plus R minus 1 is equal to summation AR x raised power C plus R plus 1 minus times. Okay. I have omitted certain steps. We have taken AR C plus R common. What remains is C plus R minus 1 and plus 1. So C plus R, C plus R. This is square. And from this you can see this is the second method. See? If I will, okay, let me operate it. This is A0 C square x raised power C minus 1. A1 C plus 1 square x raised power C. A2 C plus 2 square x raised power C plus 1. A3 C plus 3 square x raised power C plus 3 and so on. Okay. Right hand side is nothing but A0 x raised power C plus 1. A1 x raised power C plus 2. A2 x raised power C plus 3 and so on. Now collect coefficients of different powers of x. Starting from the lowest, you will get A0 C square equal to 0, which means C equal to 0 and so roots are repeated. You have got two equal roots. For that you know the case. Now you can find A1, A2, A3 so on. Collect coefficients of different powers of x starting from the lowest. You have started, you have got C. Now next coefficient is A1. A1 C plus 1 square. C plus 1. Sorry. Okay. C minus 1. Coefficient of x raised power C. Is it x raised power C is not there. So it is 0. This means that A1 is C1 upon C plus 1 whole square, which is 0. Okay. Now A2 C plus 2 square. Quotient of x raised power C plus 1. A2 C plus 2 square is equal to minus A0. So A2 is minus A0 C plus 2 square. Again A3 will be 0. You see, coefficient of x raised power C plus 3. C plus 3. A3 I have taken A0, then A1, A2, now A3. A3. This is A3 C plus 3. This will be in terms of A1. C plus 1, C plus 2, C plus 2. Sorry. Okay. This is coefficient of x raised power C plus 2. C plus 1 I have already taken. I have got A2. Okay. You see, coefficient of x raised power C plus 1. X raised power C plus 1. Now coefficient of x raised power C plus 2. C plus 2. This is C plus 2. Oh. C plus 1, C plus 2. This is C plus 2. Which is in terms of A1. But A1 is 0. So A3 is 0. So you will get A4. Coefficient of x raised power. So your A4 will be again A0. This is minus. This will be plus. C plus 2 square. C plus 4 square. And so on. This is minus C plus 2 square, you will get C plus 4 square, and so on. C minus 1 C, C plus 1 C plus 2, C plus 1 C plus 2, and so on. Okay, some coefficients will be 0, some coefficients are given. You will get A0, A2, A4. A0, for A0 you have got C. You will get only A2, A4 and A6 and A8. All A1s are 0, A3s are 0, A5s are 0. Okay, you can see it from here only. Okay, now you have got it. You will substitute in Y. If you want me to do it, let me do it one more time, and then we'll be taking 2 more cases in next, because it will be huge. Your Y is x raised power C, A0, A1x, A2x square, A3x cube, A4x4, and so on. This is A1 is 0, A3 is 0, but A2 is in terms of A0, A4 is in terms of 0. I will be taking one step down. It is A0, x raised power C, 1 minus, what's x square? Okay, it was C plus 2. It is x square by C plus 2 square. Then x4, C plus 2 square, C plus 4 square, and so on. Do it. This is Y equal x raised power C, A0 function of xc. You have to substitute 2 values in Y, in this 2, if this is 2, 2, and it is partial derivative, del Y by del C. You have to differentiate this partially with respect to C, which is Y log x, A0 x raised power C, del by del C of x raised power function of xc. Let me, because you will be confused. First is okay, you have C equal 0 and 0. First you have to substitute 0 here. You will get Y equal A0, 1 minus x square by 2 square, x4 by 2 square into 4 square minus so on. This is first solution, say U. For second solution, this is U, okay? Del Y by del C. It is Y log x, A0 x raised power C, del by del C of function of xc. Means Y log x del by del C of function of xc. This is function of xc. Sorry, this one. 1 minus x square C plus 2 raised power minus 2. Then plus x4 C plus 2 raised power minus 2, C plus 2 raised power minus 4, UV form, okay? And so on. Do it now. Why? Now you can do it. You can differentiate it once. It is quite easy. This is minus 2 times and so on. Okay? You will do it. If there is any problem, you can ask me. There is nothing to do. You have to differentiate it once only. You will use product here. This is minus 2c plus 2 whole square, whole cube. Then again, if you differentiate it by product method, this is minus 2c plus 2 raised power minus 3. Then this as it is. Then this as it is. This is minus 2 or minus 4. Then again minus 2, and this is c plus 4 over here. Minus 2 c plus 4 raised power minus 3. Okay. Then you have to put c in this only. You will get another solution, say v. Rest will follow. Okay. Thank you.